right, you guys, let's just walk through some trig problems here. So a pilot's flying at 10,000 feet and wants to go up to 20,000 feet. So that's a total of starting from this point, ending at this point, going up 10,000 feet, okay? And he says over the next 50 miles. So this is over the course of 50 miles. All right, and then what should his angle of elevation be? So angle of elevation is always going up from the horizontal. So this is the angle we're looking for. All right, so let's find that angle. Well, in terms of that angle, this is the opposite side, and this is the adjacent side. We do not know or care about the hypotenuse here. What we're going to try and do then is use a trig function. So remember, it's so, ka, toa. So the one that's opposite over adjacent is the tangent. So I'm going to move this over a little and shrink it. Okay. So what we have is, and careful of units, is we have the tangent of whatever that angle is equal to 10,000 feet over 50 miles. But now those units don't match. So let's go, that's actually 10,000 feet over 50 times. And that gives us the hint, that's 5280 feet. Okay, so now feet and feet on top and bottom cancel. So we get the tangents equal to that. So we could figure out what that means. Like, for example, we cancel out 2 of the zeros with these 2 zeros. And we get 100 over 5 times that. So it's what? 2,500, 2,600, and 8 times 540. Is that right? Let's just check. So that's 500 times 2, 2,500. What am I doing? Let's just do this. Ready? Watch this. 5 times 528. We're going to use the app here. 2640. Nice. Okay, let's get back over there. So we have 10. So that cancels. So we have 10 over 264. So now let's rewrite that and go, well, if we know the tangent of theta is equal to 10 over 264, well, then that means theta is equal to the inverse tangent of 10 over 264. Okay, so let's just go over to our calculator then and go inverse. So trust this. So arctan, that's the same thing as tangent to the -1 of 10 over 264, and what's that equal to? 2.16 degrees. Now I want to change this really quick to be in, make sure we're in radians versus degrees, and so what are we in here? Oh, it's down at the bottom. So if this was in radians, this is in degrees. So I could switch down at the bottom of my screen in the bottom left corner. So it's not a very steep degrees. So we're in 2.169 degrees. Let's go back over there. That's the angle is around 2.169 degrees. And it said to the nearest tenth. So that's 2.2 degrees is what we were looking for as an angle of elevation. Or you could leave it for me in exact form like that, though you should simplify the 10 over 264. All right, so let's go to the next one. Find the angle of elevation of the sun when a 7.6 meter flagpole casts. So we have a 7.6 meter flagpole casting an 18.2 meter shadow. So again, we have an angle here. Right? That's the angle of elevation, is the angle up from the horizontal. So again, we have the tangent of theta equals 7.6 over 18.2. So theta is equal to the inverse tangent or arctan. Those are the same operation, just 2 different ways to write the same operation of this. So then tangent, or I mean the angle is going to be about, so 7.6 divided by 18.2. So let's trash this. Arctan of 7.6 over 18.2. Let's try that. I scribbled a little bit. Oh, see, we had, let's try, nope, 7 point. Dang. Oh, I was hoping this would be so smooth. Let's try it one more time. Arctan 7.6 over 18.2. There we go, 22.66, or to the nearest tenth, that's 22.7 degrees. Okay, let's keep going. A salvage ship uses sonar to determine that the angle of depression to a wreck, so angle of depression meaning the angle downwards in this picture, is 13.25 degrees. The depth chart shows the ocean floor is 40 meters deep there below the surface. How far must the diver be lowered from the salvage ship, or how far must he walk once he's lowered? So if he goes straight down from the ship, how far over does he have to walk? So in other words, it's saying find x here. So if this is the right triangle, again, this is the opposite side, this is the adjacent, and we don't care about the hypotenuse. So this time we have tangent of, and we're given the angle is 13.25, and that's equal to 40 over x, or opposite over adjacent. So I'm going to multiply both sides by x. Okay, that cancels there, and we now have x times tangent of 13.25 equals 40. And then I'm just going to divide both sides by that tan, because remember, the tangent of 13.25 is just a number, so this is really just like 3x equals 40. We just divide by that number on both sides, same thing. So we're saying divide by that number, tangent of 13.25 on both sides. Whoops, 25. And so we get that x is exactly equal to 40 divided by the tan of 13.25, or that's approximately whoopsie. So that's approximately 169.7, or rounding up, 169.9. Perfect, okay. Let's go to the next one. So from the top, actually to pause here to go back to Zoom, I'll be right back. All right, let's just keep going. I'm going to start using an off the iPad calculator just for speed, and trusting you guys know how to use a calculator. All right, so from the top of this 150-foot tower, got that in the picture, an air traffic controller observes an airplane. Okay, he's on the runway. So how far below the base of the tower is, so it's just saying how far from the base of the tower. So in other words, what's this distance across if this angle of depression is 12 degrees? Well, the angle of depression, because horizontals are parallel, is the same as this 12 degrees, or you could redraw the height here as 150 degrees, whichever way you want to do it, working in this top triangle or this bottom triangle. They're congruent triangles, so it doesn't matter which one you look at. I'm going to work in the bottom here, and I'm going to say it's the tangent of 12 degrees equals 150 over x. So just like we did in the last problem, multiplying by x on both sides. So x times the tangent of 12 degrees is equal to 150. Dividing by the tangent of 12, I get x equals 150 divided by the tangent of 12 degrees. I plug that into my calculator. 150 divided by the tangent of 12 degrees. Careful of my parentheses. And I get that it's around 705.6945 ... And so you could round that to 705.7, and that's in feet. You could also leave this as an exact answer on a test or quiz. For me, I like it like that. One thing you might want to check on your calculator really quick is just plug in the sine of 90. The sine of 90 degrees should be equal to 1. If it's not, if it's equal to like 0.86, you're accidentally in radians, which is another form of measuring degrees, just measuring angle size. All right, so two boats are observed by parasailers 75 above the lake. So this guy's 75 above a lake, so that's right angle with the ground, okay? He sees two boats, so the boats are on the lake. Here's this dude up here in the air with a cool little parachute. What? Just having a blast. All right. And angles of depression are 12.5 and 7. So that means from horizontal, one is down 7, and one is down more, 12.5 total. okay? And one he sees a boat, and then the other one he sees a boat. And the question is, how far apart are the boats? Well, really what it's saying is what's like the distance to the first boat, and separately what's the distance to the second boat, and then we just subtract, right? So we cannot use trig yet in a non-right triangle. So this slanty triangle, you don't do any sort of like tangent sign in that slanty little weird triangle. Instead, we draw two separate triangles. We say, oh, well, this triangle here, right, is 7 degrees. That's the further distance one, and 75 feet vertical. And then the closer distance one is 12.5 degrees and 75. And we're just looking for two totally separate distances, and then we're going to subtract. Okay? Now, remember, I said horizontal parallel to horizontal, so I placed the 12.5 here, degrees, and the 7 degrees here. You absolutely could have just drawn the 75 feet down over here and worked in these right triangles up top. It doesn't matter which ones. Okay, I'm going to shrink my picture a little bit so we have room to work. I'll put that up there. Oh, look at my little happy parachuter. He's got a little smile on his face. Who wouldn't? Well, I guess if like your parachute breaks or something, that'd be sad. But whatever, it'd be a wild ride. All right, so let's do this. We got, man, so many tangents. So again, we have the tangent of 7 degrees. And I know that because this is the opposite side over the adjacent side. Oh, that's not how you spell adjacent. So tangent of 7 equals 75 over d2. And then we also know that we multiply, we get d2 times tangent of 7 degrees equals 75. Then we divide, so the second distance is 75 divided by the tangent of 7. We do the same thing for the first distance. So the tangent of 12.5 equals 75 divided by d1. Rearranging the same way, we get distance 1 is 75 over the tangent of 12.5. And then all we do is subtract. So the distance between the two boats is 75 over tangent of 7 minus 75 over tangent of 12.5. I'm plugging that all into my calculator. That's the exact answer. Okay, but that's around equal to, so I'm just going to go 75 divided by the tangent of 7 degrees. I'm ending my parentheses there, and then I go that all minus, and then 75 divided by the tangent of 12.5, again ending my parentheses. So then we get that's around 272.5. And then what were the units here? Meters above the lake. So they're about that many meters apart. Or you could separately go 75 divided by the tangent of 7. The first boat was about 610.82 ... minus 75 divided by tangent of 12.5. We don't need to. And go, oh, that's about 338.30 ... And when you subtract those, that's where the 272 came from. Is two separate boat distances and then subtract. All right, so golfers standing at the tee looking up to the green on a hill. If the tee's 36 yards lower and you have the 12-degree angle of elevation, find the distance from the tee to the hole. So this one, I'm assuming they mean distance like in the straight line like this. That's a little ambiguous. So let's see this one more time. So standing at the tee looking up at the green on a hill. If the tee is 36 yards lower than the green, the angle of elevation of the tee to the hole is, find the distance from the tee to the hole. So yeah, I'm pretty sure it's looking at for this distance. I could be wrong. Okay, so this is opposite over this is hypotenuse. And so now what we're going to say, now this is hard because it's like, is it talking about distance on the ground or is it talking about like bird's eye view? Because like if you're talking about like journey from a mountain, it might only horizontally be to get to the summit. It might only be 100 feet. But like because you've got to climb 10,000 feet or something, it might be a bajillion feet to get up. This might be like, I don't know, 11,000 foot climb for you to get up 10,000 feet using the Pythagorean theorem there. Even though you're only going like looking straight down on a map, you're only going on a map 100 feet. And yet because the vertical up and down climb is so different. So I'm going to take it as let's go to the top of this hill, distance you're walking to get there, or the ball has to travel, okay? All right, so anyways, if we want opposite over hypotenuse, that's so, like from SOHCAHTOA, so SOHCAHTOA. So that's the sine. So we get the sine of the angle equals the opposite 36 over the hypotenuse. Let's call that distance. Okay, so multiplying by d on both sides, we get d times sine of 12 degrees equals 36, dividing by sine of 12, because sine of 12 is just a number. We get that's divided by sine of 12 degrees. And so that's exactly equal to this, or approximately equal to 36 divided by the sine of 12 degrees, and that's 173.15, and that was in yards. Okay, let's go down here. So after flying at an altitude of 500 meters, a helicopter starts to descend. When its ground distance from landing pad is 11, so that means ground distance, that means on the ground, like here's this cool looking helicopter thing, choo, 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 and its ground distance along the ground that we were just talking about, right? So that's 500 meters. Oh no, sorry. It from the landing pad is 11 kilometers. So 11 kilometers is 11,000 meters. All right. What is the angle of depression for this part of the flight? So after flying at an altitude of 500 meters, a helicopter starts to descend when he's that far from the landing pad. What's the angle of depression on average to get from there to there? So what's this from the horizontal angle down we go? Well, that's the same as the angle of elevation, because that's, again, as long as you measure it from the horizontal, those are alternate interior angles, and these are both horizontal, so they're the same. So we get that the tangent of the angle equals 500 over 11,000, because we had to convert meters and kilometers to be the same unit. So we get that the tangent of theta equals 5 over 100 cancels out over 110. And so that's 1 over 22. So we get, if the tangent of theta is 1 over 22, then that means theta is equal to the inverse. I'm going to write arctan this time, but you could write arctan of 122, or you could write tangent inverse 1 over 22. Mathematicians don't really like this notation because the -1 almost makes it look like 1 over tangent. So I'm going to go with arctan here. So that's the exact answer, but we could say that is approximately equal to, so I'm going to go arctan 1 divided by 22 and my parentheses, and that's 2.60 degrees. All right, so sledding run is 300-yard long with a vertical drop. So I'm guessing then that the long means this way. So you ride down 300 feet along this slope with a vertical drop. So you're dropping vertically from the original height, that horizontal, you're dropping a total of 27.6 yards. And the units are the same, yards and yards. Find the angle of depression of the run. So what's this angle going down? So this is the opposite side, and this is the hypotenuse relative to that angle. And so that means we're dealing with the SO of SOHCAHTOA, opposite and hypotenuse. So we get the sine of that angle is equal to the opposite, 27.6, over the hypotenuse, 300. So that means just rewriting that theta is equal to the inverse sine of, and notice how I'm just switching between the signs. It's okay, they're interchangeable, arc sine or sine -1. And so that's the exact answer. And you could simplify that, but that's okay. Or you could say the angle is around, and you plug that into your calculator. So the inverse sine, 27.6 divided by 300, end of the parentheses, about 5.2, and rounding the second digit, 8 degrees. All right, so the Monongahela Incline, that's an interesting name, overlooks the city of Pittsburgh, Pennsylvania. Refer to the information at left. I don't have a picture here. I must have forgot it. I'll come back to number 12 with the image. Poof! Oh, magic. Look at that. It's amazing. Okay, So it's 635 feet long with a vertical rise. Woof, that is crazy. I lived in Switzerland and they have these, I don't remember what you call them, but they were just trains that went up these crazy inclines and you just hop on the little trolley train and it would just take you up to the top of these rad little mountains overlooking lakes. It was so cool. I don't remember what those were called. Okay, so a vertical rise of 369.39 feet. Okay, the length, I'm assuming you're actually talking about track length, and so it's 635 feet long. All right, and then it's saying it was built at a cost of $50,000 and open on that. It's still used today. Okay, so refer to the information left, the incline of the railway. So what's that angle of elevation here? Again, we're dealing with the opposite and the hypotenuse. And so this is going to be the sine of the angle of elevation equals 369.39. That's the opposite over the hypotenuse, 635. So rewriting that same expression, that means the angle is equal to the inverse sine or arc sine of 369.39 all over 635. And we could approximate that. So that's the exact value, or that's approximately inverse sine of 369.39 divided by 635, which is around 35.57 degrees. That is an insane incline. I'm just double checking that work. Woo, that is a crazy steep one. All right. Let's see, amusement parks. From the top of a roller coaster, 60 yards above, so we're at the top of the roller coaster, 60 yards up high. The rider looks down to see a merry-go-round. And so two separate things. We already did a problem like this with the two boats, right? And so it's saying how far apart are they. The big idea here is you have two separate triangles. You have this one that's 60 and the angle of depression from the horizontal is 8 degrees. And so this is an 8 degrees. And then you have the same picture going on with a 60 and now an 11 degrees here because, again, alternate interior, the angle of depression was 11 degrees, right? So now we could just find the distance to both of these, right? And so then subtract. And so we go, the distance to the farther one, right, is tangent of 8 degrees equals 60 over d1, multiplying by d1. We get this. Dividing by the tangent of 8, we get d1 equals 60 divided by the tangent of 8 degrees. And then similarly over here, we say the tangent of 11 degrees is 60 over d2. We end up rearranging and we get d2 the same way as 60 over tangent of 11 degrees. We're going to subtract the two. This one is a smaller angle, so it's further away. So this is the longer distance. Here we're closer to the tower, so we have a bigger angle we're looking up at. But, I mean, whatever. If you subtracting a negative, you did it backwards. And so the distance between them is d1 minus d2, or in other words, 60 over tangent of 8 degrees minus 60 over tangent of 11 degrees. So that's the exact expression. And then we could approximate it, saying that's 60 divided by tan of 8, and then all that minus 60 divided by tan of 11. Or they're about 118.25, and that was what in yards apart, right? And we could always just double check. We go 60 divided by tangent of 8. This first one was about 426.92 ... And then we minus 60 divided by tan of 11. And we said, oh, that's about 308.67 ... And so when you subtract those, you get about, 120-ish. Perfect. Okay, civil engineering. For these, use the following information. A percent grade of a highway is the ratio of the vertical rise or fall over a given horizontal distance. So in other words, we have the horizontal and the vertical, so that's aka the slope, right? So the ratio is expressed as a percent to the nearest whole number. Suppose the highway is a vertical rise of 140 feet for every 2,000 feet horizontal distance. What's the percent grade? So it's just rise over run. And so we say, oh, well, that's just 140 over 2,000 we could simplify that to 14 over 200. Since we want it as a percent, we want it out of 100, so that's 7 out of 100, or exactly 7%. You could have also just plugged this into a calculator inelegantly and said that is equal to 0.07. I was just double checking, which is 7%, right? So that's 14. And then 15 says find the angle of elevation. Okay, so what's the angle of elevation there that would create that? So here's the tangent of that angle equals the opposite over the adjacent, or in other words, the tangent of theta equals 7%, or 0.07. So then what's the angle, right? So the angle then is equal to exactly the arctan of 0.07, or in other words, it is around the inverse tangent of 0.07, which is 4.004 degrees. So right around 4 degrees. Okay, very cool problem. So 7% rise in terms of slope, rise over run, is equal to a 4-degree angle of elevation. All right, so skiing. A ski run has an angle of elevation of 24.4. So we've got this slope of 24.4 degrees and a vertical drop of 1,100. So the vertical is 1,100 feet. To the nearest foot, how long is the ski run? So here's the ski run, right, where you're actually skiing. And so you're saying, oh, that's some distance, I don't know, let's call it x. And so this is the opposite. This is the hypotenuse. Man, we haven't used cosine at all. What the heck? So this is the SO of SOHCAHTOA. So that's sine of 24.4 equals the opposite, 1,100 over x. So multiplying both sides by x, that cancels. We get x times sine of 24.4 equals 1,100. And then we're going to divide both sides by the sine. So we get x equals 1,100 divided by sine of 24.4. So that's the exact value. And then we could say, well, we can approximate that to be the sine of 24.4. So that's about 2,662.76. And what was that in feet? Does that seem about right? Right, this was 1,100. Hypotenuse is going to be longer. This was at 20-something degrees, so it's actually pretty long. So yeah, I would say that's about right, just approximating. Use the following information. So we got Yellowstone and Old Faithful on a perfect day. I want a freaking perfect day. That sounds great. Whew. Okay. His eyes are 6 feet from the ground. Okay. He's a pretty tall guy, and he's like 6'2", 6'3". And Geyser can reach heights of a range around 90 to 184 feet. That's pretty tall. What's the top of a geyser, though? It just fades away in a gradient. How do you say the top? What's that even mean? I mean, the water particles are just going to keep floating upwards. Interesting. So anyways, if Kirk stands 200 feet from the geyser and the eruption is 170, so he's over here for 17. He's over here. He's not on the ground, right? So here's his eyeballs, and that's 6 feet from the ground. Okay, and he's standing 200 feet from the geyser, and the eruption's 175 feet. That's from the ground, okay? Not, so that's like, 175 minus 6 is how far above his eyes. What's the angle of elevation to the top of the spray to the nearest tenth? Okay, so I'm assuming they mean from his eyes. Yeah, so I'm assuming they mean from his eyes. Maybe they mean from his toes, but I don't know. That's weird. They told us his eye height and they would ask angle of elevation from his toes. So I think he's looking up at this. So he's 200 feet from it. It's 175 feet up. Subtract the 6. And in this right triangle at the top, this is 169 feet above his eye level. So we're looking for this angle. So we get the tangent of theta is equal to opposite 169 over adjacent 200. So these are about the same. So it's going to be about 45 degrees and then a little less because this side is smaller. So maybe I'm guessing like 38 degrees. That's my guess here. Okay, so we got exactly. So then we have theta equals exactly the arctan of 169 over 200. And so that's approximately equal to the inverse tangent of 169 divided by 200. And those parentheses, and we get 40. Oh, I should have gone a little higher. So 40.005 19, and then we have to round up. So carrying, that's 20 degrees. Okay, so we have the exact and the approximate. And then 18. Ooh, I did not leave enough room for 18. In the afternoon, he returns and observes the geyser spray reaching a height of 123 feet when the angle of elevation is 37. So how far is he away now? Because he's not standing in the exact same spot, right? So he's in a different spot. Now this time, I'll draw him over here. Okay, again, his eyes are off the ground. He sees this thing being 123 feet high. So that's 123 minus 6 gives us 117 feet from his eye level. He's looking up at an angle of 37 degrees. So the question is, how far from the geyser is he? So here's the distance that he is from the geyser. So in this case, it's the tangent of 37 degrees equals the opposite 117 over the distance. Remember, I just subtracted the 6 because his eyes looking up is 6 feet above the ground. So multiplying, that gives us d times tangent of 37 equals 117. And rearranging, we get d equals 117 over tangent of 37 degrees. That's the exact answer. Or plugging it into a calculator, 117 divided by tangent of 37 is about 155.26 feet. Okay? See, bird watching. 2 observers are 200 feet apart, okay? Got it. They're dots. That's how we represent things in geometry, right? So we started with day 1. So 200 feet apart, in line with a tree. Ooh, containing a bird's nest. So we got a tree, and there's the bird's nest. That's another point. The angles of elevation to the bird's nest are 30 and 60. So one's 30 degrees up, and one's 60 degrees up. How far is each observer from the base of the tree? So by ASA, we have a triangle here. So we should be able to do some calculations and figure this out. What we're really looking for here is this common side in the middle. Can we find this x, right? Like that's what I think we need to do. Or we could say, all right, so this is x and this is 200 minus x, and like this is y. So these are all the possible real variables we need, right? We're probably not looking for this and this. Because here we have a relationship, they add up to 200, and here we have a relationship that they're the same, so we're probably going to use those to figure this out. Well, if you know special triangles, what the heck? These are both 30, 60, 90. What the heck? Let's go in and figure this out, right? So we don't need a y here, right? If this is a 30, 60, 90, we could just get along with x, and this is 30, 60, 90. So remember, this one on the left is similar to 30, 60, 90. So this is a 1, 2, root 3. And this one's similar to, just oriented the other way. We have a 30, a 60, and a 90. This is a 1, 2, and a root 3. So if this is 200 minus x, well then this is 200 minus x times root 3, using the right special triangle there. And on the left, we have, wait a second, this is the root 3 side, so to get to that, it's x divided by root 3. So what the heck? Those two must be the same. We didn't even need to use a sine or cosine here because we have our special right triangles. So just using this proportion, we can get this middle height in the left triangle, and using this proportion, we could get the height in the right triangle, but they must be the same. So what we know is that x over root 3 must be equal to 200 minus x times root 3. Well, look at this. Watch this. Oh, snap. We multiply both sides by root 3, and look at that. Everything got so much easier. This totally cancels out, and we just get x. But on the right, we have 200 minus x times, and what's root 3 times root 3? It's just times 3. Oh my good golly. That got so easy so quick. Okay, so this is x equals 600 minus 3x. So adding the x to both sides, we get 4x equals 600. So dividing, we get that's 150. So that was 150 over here and 50 over here, which makes sense. The closer they were looking up steeper, and the further they were looking up at a smaller angle. And then we could just go ahead and we could double check everything, and we could say, well, in this left triangle, if this is 30 degrees and this is 150, and this is 60, then that means this is 150 divided by root 3. Or just dealing with like simplifying radicals, we go, that's times, my pen's broken here, crazy. Okay, root 3. So that's 150 root 3. Oh, 150 root 3 all over 3 on the bottom. Or in other words, that's 50 root 3. And in the right triangle, just double checking our work just to make sure, we have 60 and this was 50. And so again, we just go, times by root 3 to get here. So that's 50 root 3. So check, it worked out just to double check our work. So they're each 50 and 150 from the middle. Cool problem, just special right triangles, okay. Okay, so the altitude of the base of a cloud formation is called the cloud ceiling or the ceiling. Find the ceiling one night when a meteorologist who studies like weather and climate and all that directed a spotlight vertically at the clouds using a theodolite. So I put some pictures of theodolite. This was a great invention. It's basically just a telescope with a dial saying what degrees you're pointing at. But oh man, they can get so accurate. Modern day, you see the guys at the side of the road using these, and they're laser calibrated to be insanely precise. All right, so anyways, using a theodolite 83 meters away, they measured an angle of elevation of 62 degrees. And then also, it's not sitting on the ground, right? It's above the ground a little bit. So the idea here is, how tall is that? Well, we have this picture here. We have a 62.7 degree angle. We are 83 meters away. We want to find this height, and then afterwards we need to add 1.5 meters because it wasn't on the ground. So we say, okay, well, the tangent of 62.7 is equal to the height over 83, and then we multiply by 83, and so we get the height equals 83 times, so we're just multiplying by 83 on both sides, right? That was a crazy 83. And so we end up getting 83 times the tangent of 62.7, and then we just need to add 1.5 at the end. So the exact answer here would be this. And then the approximate answer would be, I'll pull out my calculator. So 83 times the tangent of 62.7, end the parentheses, we add 1.5, and we get about 162.31, ... Okay, and that was rounded actually, so no ... And just to double check, if this was the 30, 60, 90 triangle, this should be about 83 root 3. So let's just do that really quick. 83 root 3, and then we just add 1.5. And so it should be about, that was about 145. And so yeah, it was a little bigger than 60, so it was a little bigger than 145. Great. That's just a way to double check your work at the end of a problem using those 30, 60, 90. Okay. A doctor's using a treadmill to assess the strength of a patient's heart rate. At the beginning of the exam, the 48-inch treadmill is at an angle of incline. So we have a treadmill, which is physically this long. It's at an incline of 10 degrees. So that's the angle of elevation. All right. So then how far off the horizontal is the raised end? Okay. So this one is how far is it up? So what's the height here? So again, that's the opposite over the hypotenuse. So this is the sine. So this is 21. So we get the sine of 10 degrees equals height over 48. And this is in inches. We multiply both sides by the 48. And we get the height is 48 times the sine of 10 degrees. And so we punch it into the calculator, and we get that's approximately equal to 8.335, or let's just stop it there, 8.3 inches. Okay. And then it says during one stage of the exam, the end of the treadmill is 10 high. So it says at a different point, we have the same treadmill, so it's still 48 inches long, but the incline is different. Now it's 10 inches up on this side, and they want to know what's the angle of incline, okay? So this time, we still have the same sine function, but now we don't know the angle, but we do know the opposite side's 10 over 48. So we go, okay, well, theta is exactly equal to the inverse sine of 10 over 48. That's just the same expression written two different ways. And then we just say, well, that's approximately equal to what? So it's approximately, it should be a little bigger than 10 degrees, right? Because we went from 8.33 inches up to 10. So inverse sine of 10 divided by 48, that's about 12.02 degrees. All right, and then 23 says, suppose the exam is divided into 5 stages and the incline of the treadmill is increased 2 degrees for each stage. Does the end of the treadmill rise the same distance? No. So at the beginning, going from flat to 2 degrees, it's going to raise the most. But at the end, when it's already steep, if you're like this and you go 2 degrees more, it's mostly swinging sideways, not vertically. Whereas at the beginning, it was mostly swinging vertically and only a little bit backwards. So the short answer is no. But we could just check some intervals. So that was from 10 degrees to 12 degrees. We went up from 8.3 up to 12 or 10 inches. So 2 degrees led to what, about 1.7 inch gain? Let's do a more extreme case. Let's do a quick, like, I don't know, let's say this was 60 degrees. And so that would mean 30, 60, 90. If this is a 48, then this is a 24, and this is a 24 root 3. And then let's figure out what it was with the 62. Okay, so let's say 62 degrees. How much did that change? So this is still 48. Now we're looking for the height. So the sine of 62 is equal to height over 48. And so that's height equals 48 times the sine of 62. So let's see what those two heights are. So 48 times the sine of 62 degrees. So that was about 42.38 inches. And then the one right before, which was 24 times root 3, was 41.56. So as we got up to 60 degrees, instead of around 10 or 12 degrees, instead of going up 1.7 inches for every 2 degrees, now we're going up, hold on, just subtracting these. So 42.38 minus 41.569. And so that was, we went up just 0.81 inches. So now we went up almost half as much when we were at the 60 degrees. And if we went when we were at like almost 90 degrees, it would be even less, right? So that's cool. Cool problem. All right, so next one. Quan Yang uses a theodolite, so same theodolite, to measure the angle of elevation of the ground to the top of Ayers Rock. He walks half a kilometer closer. So in other words, we have this picture. We have this guy standing here who says, oh, this was 15.85 degrees looking up. Then he walks closer. So this distance here is half a kilometer. So let's just say 500 meters. That's a half a kilometer. And now the angle of elevation is 25.6. How high is this? Okay, well, let's check. We have a system of equations here now. So we have some unknown variable here, y. And so we know that the sine, no, sorry, this is the tangent. We know that the tangent of 25.6 degrees is equal to x over y, right? But we don't know either of those. But we also know the tangent of 15.85 is equal to x over, and now we've got this whole expression, y plus 500. Oh, wait a second. System of equations, two variables, two equations, we can solve this. So let's multiply to solve for the x, or to isolate the x. So in the first equation, multiplied by y, we get x equals y times tangent of 25.6. We're doing the same thing we did in this problem up here, where we wrote this height in two different ways in relationship to x. So we're doing the same thing here. We're saying x, in terms of the smaller triangle, is y times tangent of 256. In the other one, x is equal to, so we multiply by the y plus 500 as a group, and so we get x equals, in parentheses, y plus 500 times tangent of 15.85. Now the algebra gets a little trickier just because we have these different tangents. So we get setting those equal, we get y times the tangent of 25.6 equals y plus 500 times tangent of 15.85. I'm going to stick with the tangents until the end of the problem. So I want to get an exact expression here. So what I get is y times tangent to 25.6 equals y times the distributing in tangent of 15.85, and then that's plus 500 times the tangent of 15.85. So really what's going on here, if I were to write this in something different, this is like saying I have 5x equals 3x plus 5. So I have y number plus number. So I need to get all the variables to one side. So subtracting, I get y times tangent of 25.6 minus y tangent of 15.85. So all the y's are on the left now is equal to just number on the right. Y tangent 15. And you could have plugged this in and been dealing with decimals, but you shouldn't round a problem in the middle. So factoring out the y, now I have y times this number, tangent 25.6 minus tangent 15.85 equals number. So now it looks like this. I subtracted the 3x, got the x, so now I have 2x equals 5. So all I got to do is divide by this number. The number is just a little scary looking, but it's just a number, right? So tangent of 15.85. And so y is equal to exactly 500 tangent 15.85 all over tangent 25.6 minus tangent 15.85. Right? That's the idea. So it was a system of equations. So that's the exact value of how far he is. We're not looking for that. We're looking for the value of x. So we're going to have to plug this back in. So I'm going to solve for y really quick. Okay, I'm going to take out my calculator. It's a long expression to write in, but that's okay. So 500. So I'm going to start with parentheses, right? I have a graphing calculator, so it can handle these parentheses. So 500 times tangent of 15.85, end that top parentheses. Okay, and then I'm going to divide by in parentheses, tangent of 25.6, and then minus, and then tangent of 15.85, end those parentheses, and we get, this is 700, whoops, I wrote it wrong, 727 point, I'm going to keep a lot of decimals here, okay? So I get that. Now, I just have a simple problem of solving for x in this triangle, but I already have it written right here, so I'm just going to plug it in. So I have that number, I just got the 727 with lots of decimals, times the tangent of 25.6, which is equal to a total height of 348.42 ... So I'm going to round it up to 348.4 meters. Okay, so let's do a couple more problems here. We got aerospace. So on July 20, 1969, first human to walk on the moon. During his mission, they went around the moon 3 miles above the surface. At one point in the orbit, the onboard guidance system measured the angles of depression. Oh yeah, so this is just that same type of problem. And so find the distance across the crater. So same thing we already did. We have a right angle here. We have this angle is 29 degrees because it's bigger. This one further away is smaller, 16 degrees. It's a little hard to tell which one's talking about which in there. I understand that. And so really we're just finding two separate distances and subtracting. So here we got 16 degrees, right angle 3. And then over here we got 29 degrees, right angle 3, and we're just finding these two distances. So I'll call it D1 and D2, and then we're just going to subtract. D1's longer, so the total distance is D1 minus D2. So this is tangent of 16 degrees equals 3 over D1. So multiplying by D1, and then dividing by tangent, so we get D1 is 3 divided by tangent of 16. And then over on the other side, we get tangent of 29 degrees is equal to 3 over d2. Same rearranging. Whoa, d2, not d squared. Same rearranging. d2 is 3 over tangent of 29. And so the total answer here is 3 over tangent of 16 minus 3 over tangent of 29. And I'll plug that in once here at the end. So that way I'm not rounding my numbers in the middle of the problem. So 3 divided by tangent of 16 minus 3 divided by tangent of 29. That's equal to 5.05 ... and those were miles. So the total width of that crater was around, not equal, was around 5.05 miles. Okay, I think we got one last one. Yeah, critical thinking. 2 weather observation satellites are 7 miles apart. Okay, so these are, stations, so they're on the ground, are 7 miles apart. Okay, a weather balloon is located between the stations. The angle of elevation from 1 is 33 degrees, and from 2, the angle of elevation is 52. Whoops, 52. I just floated out in the middle of nowhere. Find the height. So from station 2, find the altitude to the nearest mile. Right, so this is the same problem we did. So if this is x, this is 7 minus x. So we're just going to write this in 2 different ways. So on the left triangle, this is, let's call this height. So tangent of 33 equals height over x. So solving for height, we get x. Height equals x times tangent of 33. And on the right, we get tangent of 52 equals h over 7 minus x. Multiplying, we get h equals 7 minus x times the tangent of 52. And so now we can set those equal because it's the same height, just measured in 2 different ways. So we get x times tangent of 33 equals 7 minus x times tangent of 52. And we're just solving it like that system of equations we just did in number 24. And so we distribute the x. We get x times tangent of 33 equals 7 times tangent of 52 minus x times tangent of 52. We put all the variables on one side, so let's add that to, I should have boxed in the negative there with it. So we add it to the other side, so we have x tangent 33 plus x tangent 52 equals 7 tangent 52. And now we just factor out the x, and we go, really, this is just x times a single number, tangent of 33 plus tangent of 52. And then equals just a number, right? 7 times tangent of 52. And so then we just divide by the number, right? This is just like 3x equals 5. So we just have whatever number is multiplied by x, we divide it on both sides. So we get x equals the 7 times tangent of 52 all over tangent of 33 plus tangent of 52. And so that's the exact answer for the distance. But again, we don't want the distance. We want the height. So really, we could just take that distance and multiply by tangent of 33. So if that's x, then the height, which is just x times tangent of 33, then the height is just 7 times tangent of 52 times tangent of 33 all over tangent of 33 plus tangent of 52. So that's the exact expression. It's pretty crazy. I like Algebra 1. You might be terrified of that, and you might have been wanting to work with decimals the whole time. So let's do this really quick, though. So I have parentheses on top, 7 times tangent of 52 times tangent of 33. Okay, I end that parentheses on top and divide by, start some parentheses, tangent of 33 plus tangent of 52, close those parentheses, and we get around 3.01 miles high. Woo-wee! All right, guys, I hope you enjoyed that video.